Many students remember the exact moment math changed. One day you're practicing times tables, and the next you find the alphabet mixed into your arithmetic. While the sight of letters in a math problem often triggers a spike of panic, you actually navigate this logic every day. Consider a simple scenario. You see 3 hot dogs left on your plate and remember eating 2. You easily determine you started with 5. Solving that in your head, you just performed the algebraic equation, x minus 2 equals 3. Basic arithmetic feels simple because every piece of the puzzle is provided for you. 2 plus 3 will always result in 5. But the world is often full of missing information. To find what you don't know, you need a system to uncover unknown values based on how they relate to the facts you already have. Algebra is that system, an investigative toolset designed specifically for navigating missing data. Solving for an unknown requires us to first identify the different pieces on the board. We start with variables, like x, representing unknown values, distinct from constants like 3. Attaching them creates a coefficient. An operator joins them into an algebraic expression, like 3x plus 8. Without a target, it remains an open-ended statement. An expression describes a relationship, but to solve the mystery, we turn it into a complete thought, an algebraic equation. Adding an equal sign to create 3x plus 8 equals 24 balances the scale, demonstrating a strict equivalence. This equal sign acts as our anchor. It locks the relationship in place, allowing us to work backward and isolate the unknown variable's value. To find that value, we have to manipulate the equation to get the variable by itself without disturbing the balance. Algebraic properties provide a set of reliable maneuvers for shifting numbers back and forth across the equal sign. The commutative and associative properties let elements swap positions without tipping the scale. The distributive property multiplies a value across a group, retaining the weight. Finally, inverse properties collapse positive and negative versions of a number into 0, clearing the path to our variable. We can also use the reciprocal property to flip fractions, removing division steps to finally isolate the unknown. These maneuvers transform a chaotic jumble of symbols into a predictable, logical sequence. Using these tools to solve for x is called elementary algebra, which serves as the entry point for the rest of mathematics. This same logic of balanced relationships scales up into linear, abstract, and advanced algebra. By learning to isolate a single variable here, you are practicing the same investigative mechanics used to calculate rates of change in calculus or determine the unknown impact of interest rates in an economic model. Look at a board full of variables again. With the right perspective, a surface covered in mathematical letters becomes a landscape for focused inquiry. In this context, letters act as precise placeholders for the specific questions we are trying to answer. Algebra encourages us to step back and respect the process. It prioritizes the how, the logical steps taken to reach a conclusion, over a simple, unearned answer. This structured system eventually becomes a familiar tool you can fall back on whenever you encounter a problem and don't know where to begin. Confidence in algebra does more than pass a test. It provides the structural logic necessary to navigate the complex unknowns of the real world.